All right, so today what we're going to do is we're going to look at least or lowest common denominators, okay? And so we want to talk about what that means, what it is, and then we'll talk about how to find it, and then we'll talk about how to use it. So the least common denominator, anytime you see the word least, you should think smallest, right? Smallest thing possible. And if something is common, that means that it's in all of the things that you're looking at. And D always stands for denominator, which is simply the bottom of a fraction. So we've talked about that before. Okay. The bottom of a fraction. So I'm going to give you a definition for this. It's the smallest number. And when you move to algebra, then you'll be dealing with other types of denominators. But for us at year 8, it's just always going to be a number. The smallest number that every denominator, and capital D is always the abbreviation for denominator. I'm not going to write it out anymore. Okay, every denominator will divide evenly into. And you may notice that I wrote into slightly larger and underlined it and put an exclamation point because it's not what divides into them. That's a factor. It's what they will divide into, which is the least common denominator. Okay? So, right? So we're going to talk about how to find it and look at some examples of what it is when you have finding the least common denominator. And I'm going to show you a method that I guarantee most of you have not seen before unless you've been in one of my classes probably. Which always works, no matter how big or how small the fractions are. And it will also move on, and you can use it for when you're working with algebraic fractions, etc., later when you're in high school. And that's why I want to show you this method. Now, if you have, however, a method for finding least common denominators that always works, then that's what you should use. Okay? But if you don't, then perhaps this one will teach you how to do it. Okay? Now, there are 3 cases for finding LCD. They're all basically the same, but sometimes it's easier than others, depending on the numbers that you start with. So sometimes it's going to be a little easier than others. The first case is if the smaller denominator divides evenly into the larger denominator. Okay, if the smaller denominator divides evenly into the larger denominator, then the LCD is the larger denominator. Okay, and we'll look at some examples to demonstrate that. All right, so let's look at some examples of what I'm talking about here. So say we have 2 fractions, and the denominators are 8 and 4. Okay? Now, I'm not even worried about what the numerators are. I'm just worried about the denominator. Yeah? So what I want to do is find the LCD. Well, if you look at the first case, it says that if the smaller one divides evenly into the larger one, then the LCD is simply the larger one. And if you'll notice, 4 divides evenly into 8. Yes? So in that case, the LCD is simply 8. We like it when this one happens because it's very, very simple. Okay? Let's look at another one. All right, let's look at where we have 3 fractions. Let's say we have 10, we have 20, and we have 60. Again, pretty easy numbers. What's the biggest number up here is our 60, yes? Will 10 divide evenly into 60? Yes. Will 20 divide evenly into 60? Yes. Then the LCD then is 60. So if the smaller ones divide evenly into the bigger one, it's the bigger one. Now be careful, because it says least common denominator, but we use the big one. And that's because it's the smallest thing possible. Yeah? But it's always at least as big as the bigger number. So it can't ever be smaller. In this case, it could not be any number smaller than 60. Okay? Now, you could have denominators where that won't work. So we'll say I have 15 and 12. The bigger denominator is 15. Will 12 divide evenly into 15? No. So that doesn't always work. It's pretty rare that it does work, actually. Sorry. But when it does work, it's a great trick. Yeah? All right. So let's move on to the second case. Right? If not, and by if not, I mean the smaller one will not divide into the larger one. Okay? Then find the LCD using, now this is going to be weird, upside down division. Now, probably never heard of that before. Don't worry about it. I'm going to show you what it means. It has nothing to do with changing any operation. It's you're just going to divide like you've always done. But we're going to write the division symbol upside down. And that's just so we can keep it organized. So let me show you what normally would happen is you would use something called a factor tree for this. I don't like factor trees because if you think of a factor tree, it has you break it down and you divide. 6 will divide by 2 again, takes a 3, and now that's all the factors of 12. So it's 2 times 2 times 3, but it's untidy. Most people don't write it as neatly as I did, and it's not even that neat when I wrote it. Most of you, if you try this factor tree stuff, you start doing this weird going across the page all over the place. I've seen you. Don't start. So, yeah, you know who you are. That ain't good. So we're going to avoid that. And the way to avoid it is to use a different process that that pretty much forces you to stay organized. So here are the steps for it. First, you're simply going to write the denominators in an upside down division symbol. Division symbol upside down. Yeah. So upside down division symbol. So here's what it looks like. You know, normally the division symbol looks like that. We're just going to flip it over. Okay. So that's an upside down division symbol. Just flip it over. Turn it upside down. Okay. And what it's going to do is it's going to allow us to keep the numbers we're using separate from our answer. And that's the only reason we flip it over. You could do it with a division symbol right set up, but it's much harder. Second, okay, so let's say we have those two that we had a while ago. So we have 12 and 15 as our denominators. But that's the example that I had a while ago where I had denominators of 15 and 12. 12 won't divide into 15, so I'm going to have to find something that they will divide into. Second, all right, find a number that will divide evenly into at least 2 of the denominators. Now, in this case, I only have 2. But this method would work if you had 3 or 5 or 20. Doesn't matter. That's never going to happen. Don't panic. But you could easily have 3. We will frequently have 3. So as long as something will divide evenly into at least 2 of them, then you're good to go. All right? But if something doesn't divide into at least 2 of them, then you don't worry about it. It can't happen. So looking at these two, at 15 and 12, both of these numbers will divide by 3. Okay? These are called, any number that divides evenly into another number is called a factor. So what we're doing is looking for factors, things that divide evenly. And you're going to see that as we move forward, I'm going to use the proper terminology. I'm not going to say some number that divides evenly into it. I'm going to say a factor. So get used to learning the proper terminology. So now all you need to do is go back and divide. 15 divided by 3 is going to give you a 5. 12 divided by 3 gives you a 4. And then we're just going to look at the two numbers again. Is there anything that will divide evenly into 5 and 4 other than 1? Because if you divide by 1, you get right back where you are. No. So we can't divide anymore, right? So we're going to move to the next step. You're simply going to multiply every number on the outside to get, to get the LCD. So anything that's on the outside, and when I say outside, I mean outside that division symbol. Anything that's on the outside will multiply together. So if you look at this case, the things that are on the outside are the 3, the 5, and the 4. So I'm going to multiply those together. 3 times 5 is 15, and 15 times 4 makes 60. Now, you will often be dealing with some fairly big numbers, but just work on it, okay? But notice, anything that was not enclosed in the division symbol was multiplied together. The stuff on the side and the stuff on the bottom. Okay? And that's why we do the division symbol turned upside down. It simply separates the stuff we need to use from the stuff we don't need to use. Okay? So let's look at another example really quickly, and then when we're in class again, we'll do lots of examples together. Okay? So let's say we have, 4, 10, and 12. So we'll do 3. Doesn't make any difference, right? Pretend these are denominators. We need to find the LCD for these. Well, 4 divides evenly into 12, doesn't it? So we could use that shortcut. But 4 doesn't divide evenly into 10, does it? And 10 doesn't divide into 12. So we can't use the shortcut on all of them. That means we can't use the shortcut on any of it. So we're going to put it in our upside down division symbol. And I'm just going to ask myself, is there anything that will divide evenly into every one of those numbers? All of those are even, yes? Which means they'll all divide by at least a 2. Think small, it's fine. Now let's divide. 4 divided by 2 is going to leave a 2. 10 divided by 2 is going to leave a 5. 12 divided by 2 is going to make a 6. Now I need to see if there's anything else that will divide into all of them. Well, 2, 5, and 6, there's nothing that will divide evenly into all of them. But remember, we can divide as long as something divides evenly into at least 2 of them. So 2 and 6 would still divide, won't they? So we're going to draw another division symbol and divide out the common factor of 2. And now watch what happens. 2 divided by 2 gives you a 1. Anything divided by itself is 1. 5 won't divide by 2, so it just comes down. You didn't do anything to it, so just drop it down. Make sense? 6 divided by 2 gives you a 3. Is there anything common to 1, 5, and 3 other than 1? No. So now we're done with that part of it. We're done the division. All I need to do is multiply everything that's on the outside. And there's a lot here, but I picked it purposely for this. It's usually not this much stuff. 2, and we're going to multiply all that stuff together to get our LCD. 2 times 2 is 4. Times 1 is still 4. Times 5 is 20. Times 3 is 60. How do I keep getting 60? Okay, that's just it's just a fluke. I know, clearly it's clear. I'm going to go buy some. I need to buy some lottery tickets. All right, so 60. It's not always going to be 60, guys. So that's not, it's just the way it works. Okay? All right. Now remember I said there are 3 cases, so we need to look at the third one. And the third case is when nothing is common. And you usually can just see this, but if not, put it in the upside down division symbol and do the formal pattern. But say we have denominator of 3, denominator of 5. Well, I could put those in the upside down division symbol, but before I do that, I already noticed that nothing divides into 3 and 5 at the same time, do they? Okay? If that's the case, simply multiply the denominators together to get the LCD. They don't have anything in common, so we're just going to take 3 times 5 and get my LCD of 15. Okay? So nothing is common, so simply multiply the denominators together to get the LCD.